Imagine you're standing in a massive, completely empty space. Sand stretches out as far as you can see in every direction. If you needed to tell someone exactly where you were standing, how would you do it? Without any landmarks to point to, it's almost impossible. To solve this problem in our daily lives, we use a very simple trick. We draw straight, overlapping lines to build a grid. Think about a chessboard, or the way streets cross each other on a city map. By laying down this crisscrossing pattern, every single square suddenly gets its own unique address that everyone can agree on. Without that pattern, picking a spot is just a guess. But once you have a grid, you can point to one specific square and know that anyone else looking at the map will be able to find that exact same spot every single time. So how do we take this simple logic of a flat board game and wrap it around an enormous three-dimensional sphere like planet Earth? Map makers have spent thousands of years perfecting the way we measure and draw our world to help people find their way. This work is called cartography. Think of it like being an architect for the entire planet. These map makers realized they could solve the puzzle of global navigation by inventing imaginary lines that overlay the Earth. You can't see them on the ground, but they are essential mathematical tools that help us stay on track. Every measurement system needs a starting line, a 0 point where you begin counting. For our planet's grid, the starting line is the equator, an invisible ring circling the Earth exactly halfway between the North and South poles. This line creates two distinct halves, the northern hemisphere on top and the southern hemisphere on the bottom. This map shows how people saw the world in 1570. Notice how the continents are misshapen and the grid lines look shaky. Before everyone agreed on a universal starting line, like the equator, drawing accurate borders was much harder. Today, the equator acts as a permanent anchor, the baseline for every north or south measurement. Horizontal lines running parallel to the equator are called lines of latitude. Think of latitude like latitude. Like the rungs on a ladder, these perfectly parallel rings stack up and down the globe, staying the exact same distance apart without ever crossing. By stacking parallel rings from the middle out to the poles, latitude slices the Earth into perfectly readable, predictable sections. Instead of measuring the space between these lines in miles, map makers measure the curve using degrees. Figure 2.1 shows exactly how this math works. A line drawn from Earth's center to the equator represents 0 degrees. To move north, tilt that angle upward. As the internal angle widens, the latitude increases, reaching a 90-degree angle at the North Pole. We see this in the real world. Syracuse, New York sits at a 43-degree angle north of the equator. Christchurch, New Zealand is also at a 43-degree angle, but measured in the opposite direction, south of the equator. Degrees give us a universal language, allowing anyone to calculate their exact distance from the center. Let's see how this helps when you're actually traveling. Imagine you're planning a drive from New York City all the way to Los Angeles. By checking the latitude of both cities, you can see right away that Los Angeles is at a lower degree than New York. That tells you that you'll be heading south for much of your trip. Reaching that new latitude also changes the world around you. You're trading the cooler northern climate for the sun and palm trees of the south. These invisible lines take a massive, unknown journey and give you a clear sense of direction. By knowing your destination's latitude, you can see exactly how far south you'll be traveling long before you even hit the road. But there is a limit to what latitude can do. Knowing a city is at 34 degrees north only points you to a giant ring that wraps all the way around the planet. It doesn't give you a single exact spot. To find a specific location, you need an intersection. Our horizontal ladder needs vertical lines to cut across it and create a crosshair. These vertical lines that run from top to bottom are called longitude. Latitude is incredible for telling us how far north or south we are, but it's only the first half of the mapmaker's secret for finally putting the X on the map.